In this lesson, we discuss two related concepts that are already in use within the context of decentralized applications and smart contracts. Many contracts and legal documents, including digital documents, are error-prone. For example, a single comma placed incorrectly in a written contract cost $1 million to the Rogers Telecommunication Company. Escrow and multi-sig are two techniques that have enormous potential in addressing business contract related issues to transform business processes. On completion of this lesson, you will be able to explain the features of escrow within smart contract and features of multi-sig. Wikipedia defines escrow as a contractual agreement in which a third party receives and disperses money or documents for a primary transacting parties, with the disbursement dependent on conditions agreed to by the transacting parties. A smart contract can do all these. It can hold money and all artifacts in an escrow and allow transacting parties to negotiate on it and verify conditions to be met before the disbursement of the items in the escrow. What is innovative is that it can be done among parties that are operating beyond boundaries of trust in a decentralized world. Recall that a smart contract has an address that can hold a balance. You can transact, send or receive cryptocurrency from a smart contract. You can use three specific features of smart contract to develop escrow-based application. Include the amount of escrow as a state variable. Example, uint escrow amount. Use modifiers to specify the condition for disbursement of escrow. Define functions that apply the modifiers for verifying conditions for disbursement of the amount. Recall Grid platform. Grid plus energy application platform users replenish both coins as a deposit escrow in the smart contract agent that is used for payment conditional on the energy expended by the user. Based on the energy consumption, the smart agent sends only the payment for this consumption to the Grid Plus retailer. Grid Plus business model also requires a monthly deposit by the consumer. In case the smart agent runs out of bolts for the payment of energy consumption, the additional amount is deducted from the escrow. This is another use of smart contract escrow. It helps avoid interruption in electricity service. Holding escrow funds commonly works in conjunction with multiple signatures. This is known as the multi-sig feature. Many real-world contracts have multiple signatories for security, verification, and protection of assets, businesses, and individuals involved in the contract. In many cases, it may be required by law that multiple parties sign a document. For example, one's healthcare proxy has to be signed by the individual and two witnesses. Many business transactions warrant multiple signatures too, the CTO, IT manager, and so on. This is about access control. A signature in the crypto world is a private key of the address. Transactions are signed by this address for verification of the sender's authenticity. Security of the assets held by this address is only as good as the security of the private key. If the key is compromised, anyone with private key can drain the funds at the corresponding address. These concerns can be addressed by enforcing multiple signatures for execution of certain important transactions. The idea of multi-key or multi-sig is not new. We have seen two-key solution in bank safety deposit boxes. You need two keys to open it, one held by you and the second held by the bank. A thief cannot get to the contents of the safety deposit box without both keys having been compromised. Similarly, Bitcoin has used this idea successfully since 2012. We'll examine Bitcoin's multi-sig solution. Bitcoin has an alternative to a single key address. This is defined by a type of address called pay-to-script hash, a multi-sig address. Multi-sig addresses in the Bitcoin transactions begin with the digits 3, whereas regular addresses begin with the digit 1. A pay-to-script hash address can support a set of n keys, any m of which are required to transact, m of n. In practice, most multi-sigs are 2 out of 3, 2 out of 2, though larger values of m and n can be used for such use cases as legal documents. How do you use multi-sig? Generate a multi-sig address. It has n number of keys, m of which are required to trigger an action. Then fund the new multi-sig address with a deposit. Now you are ready to transact. Create a multi-sig transaction. This transaction will be signed with the first signature MS1, resulting in the hex string HS1. Then it will be signed by the second signature MS2, resulting in hex string HS2. This is repeated m times for the m signature, resulting in HSM. This is the required multi-signed key. It is verified by the protocol and the funds are transferred. This explains the multi-sig operation. We learned two closely related features of blockchain that are critical for business adoption of blockchain: escrow and multi-sig. We looked at some methods for realizing consensus, scalability, privacy, and confidentiality. We also explored methods for escrow and multi-signature in smart contracts, aligning them with real-world contracts. Now you are ready to use them in your decentralized application and contribute to the blockchain protocol improvements.